Hi friends, welcome to follow up. So in this video, we are going to look at problem 881, boats to save people. In this video, we are going to explain a solution format based on two pointer. So in this problem, we are given an array called people, where each element represents a weight. So we have plenty number of boats, where each boat can carry a maximum weight given by this parameter limit, and each boat can carry at most two people at the same time, as long as the sum of the weight of the people is at most the limit. So notice that this is at most limit means that the weight can be equal to the limit. In other words, less than or equal to, right? So we want to return the minimum number of boats to carry every given person, right? So here in example 1, so the limit is 3. We have 2 people and their total weight is 3. So we just need 1 boat. And in example 2, the list is in sorted order, right? From large to small. So here, the first element is 3, which is the same as the limit. So we need 1 boat. And then we have 2 here. So we cannot group 2 and 2 together because this is 4, right? We group 2 with 1, so we need another boat. Then we just left 1 element 2, so we need the third boat. So in total, we need 3 boats. So this is the example 2. In example 3, so here the list has a length 4, and the limit is 5. So if we sort this list, let's see. Let's just say this is the example 3, right? So if we sort it, so we are going to have 5, 4, 3, 3, and the limit is 5, right? So the 5 itself, 1 boat, right? And the 4, so we cannot group any 3, so we have 4, 1 boat. And we have another 2 3s, so they cannot group together, so we have 3, 1 boat, and 3, 1 boat. So for this problem, we need 4 boats, right? So this is the these are the 3 examples. So here, let's look at the constraints. First, the list has a length can be as long as 5 times 10 to the power 4. So in other words, we need to pay attention to time complexity. We cannot naively try. So also the list is not empty, right? So this is another assumption. So the weight is positive, and it's bounded above by the limit, and the limit is bounded above by 3 times 10 to the power 4. So this actually the weight, each people has a weight, is bounded by the limit. This is a consistent assumption, right? It means that we can carry all the people finally, anyway. So this is a problem statement. So here for this problem, as when we do the analysis for example 2 and example 3, you may think, so we need so some thought is is involved, right? In our analysis is involved, and also we can do it in a greedy fashion. So basically, for example 2, here we have 3. We can try to find a one that is matching this one. So for example, let me give you one more example, cook up one, right? So here we have 3, 2, 2, 2, 1, right? Let's see another one. So here, let's assume the limit is again 3, right? So 3 we need 1 boat, right? 1 boat. And then we look at 2, right? So then the question is which one we need to match with respect to this 2. So actually the thing is that we can match using the smallest one, right? The reason is that you can find the proper one. So this is the first one that we can match with this one. But when you do this, so you match a bigger one, then this is a smaller one. You can also do this, right? This is the one way. Or another way is that you can match the one with the smallest one. If this can match, then the next one, you have a possibility to match the next smallest one. This always work. So there's two rules basically. For the current one, let's say 2, you can use binary search to find the one that is added together exactly equals to the limit if it exists. Then for this one, we can match this 2 with this one, and then next to, then you can do the same thing, but that actually complicates the problem. The thing is that for this one, you can match this one, and then for this one, you just compare with the next smallest one, and then you just to see what's the number of boats in this fashion. So because of this fashion, we don't need to specifically put that. So we don't need to carry out in a mechanical way or a verbose way. We can use two pointer, right? We just need to use one pointer pointing to the largest one, and the one pointer pointing to the current smallest one, and then we do the matching. So then in between, we are going to do the counting. But let's first write the code, and then we want to demonstrate a subtle case, right? So here, for convenience of writing, I changed the name people into a capital letter P. So this is just for convenience of typing. So now here, first thing I want to sort it. So here you can sort from small to large or large to small. It does not matter. So here I'm going to use reverse equals true, right? So if you like, you can do something like this. Let's do the same thing. You can provide a key as a lambda function, let's say x. So each element, so I'm going to use its negative one, right? So this is like reverse. So then I get the, for clarity, so I get the length of this one. Then I have two pointers, ij equals 0 and n-1. So that's the beginning. So first I'm going to do this. I will write a result variable. It's better to write here, right? So then let's do the while loop. Well, I is less than j. So in this case, we want to check if pi plus pj is less than or equal to the limit. So this is the one we emphasized at the very beginning. So if this is the case, so we are going to do result incremented by 1, because we can onboard people I and people j. Then in this case, we can increment ij is I plus 1, j plus 1, right? So this is the one case. Another case is that if we want to match one person, because I is the heavier one, so if we want to match I with j, but it passes the limit, then we can only carry out person I. So in this case, we still increment the result by 1, right? Then we want to increment I by 1. So this is the full logic. So if you want to return this result, this is not the full logic yet. Because if you look at, so let me give you an example. So we have 3, let's say we have 2, 1, 1. So this for sure, let's say limit is 3. We know we need 2 boats, right? We can match this 2 and 1, and then we left 1. So originally, so you have a pointer, here you have 0, this is I, and then you have 2, this is j. So because this can carry, so you get 2 decremented by 1 and 0 incremented by 1. You get the 2 pointers match at this 1, right? But we have exited this while loop. So in this situation, we need to check if I and j is equal. If this is the case, we still need to carry out that person. In other words, so we need to check if I equals j. Then in this case, we need to increment the result by 1 to carry out the last person. If I and j do not equal, we don't need to care this situation. It's like something like this. Let's see, we have 2, 1, 1, 1, right? The limit is 3, let's assume. Then you have I as here and j and here, right? Then because you can carry this 2 person, then so j is 1 now. J is 2. J is 2, I is 1, and j is 2. Then we still can carry out this 2 person. Then you decrement 2 to be 1. So 2 comes here. So this is the new one. This is for j, right? and I now equals to j equals 1 and I equals 2. So in this case, j is less than I, so we automatically got this loop. There's no person to carry. So this is a small detail, but it's important to notice. So this forms a solution format to this problem. So you can do a check. Yeah, it passes the last example. Now let's look at the generic case. Let's see. Oh, here I should say j minus 1. In this view, let's check again. Yeah, it passes this one and the generic case. Yep. So for this problem, actually, the temp complexity and the space complexity is very easy to analyze. So the temp complexity, so here we have two parts. So sort basically is the main temp consumed. So for sort, actually we need O n logarithm n. So where n is the length of this array P. And here we have a while loop. So this while loop is O of n. So if you, because this is a superlinear, right? So this will be the overall temp complexity, because it's basically something like this. It's still bounded by this n logarithm n. As to this is the space, the time. As to space complexity, so here we sort in place. It does not use extra space. So this is the variables we introduced. So this is an O of 1, right? So here we provided one way to address this problem. You can think of other ways, or you can try to complexify the logic here. So this is not this actually is not trivial, because if you can complexify and then you can use say binary search, though it's not necessary in this problem, it basically helps you improve coding skills, right? Solving the problem itself is not the ultimate purpose for us, right? So with that said, I guess that's basically about it for this video. Thank you for watching. Hopefully you can follow up other videos to improve further. So with that said, that's it.